Hi everyone, welcome to Chemistry Final Review, and in this video we're going to learn how to draw the Lewis structure. Okay, let's go straight into it. First of all, let's review what is a Lewis structure. So, Lewis structure of a molecule shows how valence electrons are arranged among the atoms in a molecule. So it's just concerning valence electrons or electrons in the outermost shell of atoms in a molecule. Next, let's look at the steps on how to draw or write a Lewis structure. Okay, so step 1 is to sum the valence electrons of all atoms. Step 2 is to use a pair of electrons to form single bonds between bound atoms. And the last step is to arrange the rest of the valence electrons according to octet rule or duet rule for hydrogen. So the octet rule says that all atoms in a Lewis structure needs to have 8 valence electrons surrounding it, and the duet rule is only applied to hydrogen, and it says the hydrogen only needs 2 valence electrons surrounding it in a Lewis structure. Right, so now moving on, we're going to look at some examples to see how you can apply those steps. Right, so the first example, let's look at CO2. Right, so for CO2, first of all, we're gonna sum the valence electrons, right? For CO2, let's identify where is carbon. So carbon is right here in the periodic table. It's in the group 4A, so it has 4 valence electrons. And then next is oxygen, right? So we see oxygen is right here in group 6A in the periodic table. And we got 2 oxygen in CO2 molecule, so that's going to be 2 times 6. So in total, that's going to be 4 plus 2 times 6, giving a total of 16 valence electrons. Moving on to step 2, we're going to draw single bonds between bound atoms. So here I have carbon in the center and 2 oxygen on each side, and we're going to draw single bonds between the carbon and the oxygen. Now to step 3, we need to arrange the rest of the valence electrons according to octet rule. To do that, first of all, just fill octet rule for all atoms. Right, so here I'm giving the center carbon 2 pairs of electrons, and I'm giving each of the surrounding oxygen 3 pairs of electrons to satisfy octet rule for oxygen. And after we filling out octet rule for all of them, we need to count the number of valence electrons we have used so far to fill out those octet, right? And after counting, I realized that I've used 10 pairs or 20 valence electrons, but there's an issue because according to step 1, we only allowed to use 16. So that means that we have used 4 valence electrons exceeding the number allowed. So to fix that, we need to erase or eliminate 4 electrons from the structure so far, right? Eliminating 4 or removing 2 pairs from the center atom's carbon right here, and remove it from the center carbon because the center atoms can have other ways to satisfy octet rule, such as by having the surrounding atoms sharing a pair of electrons with it. So that's why we specifically removing valence electrons from the center atoms. So after removing those 2 lone pairs from the center atoms, we still need to satisfy octet rule for carbon somehow. So to do that, we'll have each oxygen on each side to share a pair of valence electrons with carbon. That way we form 2 double bond here between carbon and oxygen, and that satisfies octet rule for carbon. So we are done. This is the correct Lewis structure for CO2. And lastly, just make sure to check all the atoms satisfy octet rule. So here's exception 1. Exception 1 says that boron, B, and beryllium, Be, can have fewer than 8 valence electrons surrounding it. So make sure we keep in mind this exception as we go ahead and draw the Lewis structure for BF3. Right, so first of all, we start by summing the number of valence electrons in BF3. So we see boron is right here in group 3A, so each boron have 3 valence electrons. Next, we see that fluoride is right here in group 7A in the periodic table, so each fluoride has 7 valence electrons, and we see that there's 3 fluoride in BF3 molecule, so that's going to be 3 times 7. So in total, that's going to be 3 plus 3 times 7, that's a total of 24 valence electrons in a BF3 molecule. Now let's start with step 2, which is to draw single bonds between bound atoms. Here I have boron in the center and free fluoride surrounding it, and we draw single bonds connecting the boron with each of the fluoride. Now we just need to arrange the rest of the valence electrons according to octet rule. Right, so to do that, as always, we will first just fill octet for all atoms. So to do that, I just give the center boron a lone pair of electrons and give each of the surrounding fluoride 3 pairs of electrons, right, to satisfy octet rule. Next, very important, we need to count the number of valence electrons we've used so far. So here I just count the number of pairs I've used, and I see that I've used 13 pairs, so that translates into 26 valence electrons. And we see that there's an issue, right? Because in step 1, we count that there's only 24 valence electrons to use, and we use 26. So we need to remove 2 valence electrons. So here we will remove or erase 2 valence electrons, or 1 pair, from the center boron atoms. So this pair right here needs to be going. Right, so after removing that lone pair from boron, we are done. This is the correct Lewis structure for BF3. We see that octet rule is satisfied for all of the surrounding fluoride atoms, and the issue with boron is it only has 6 valence electrons, or 3 pairs of electrons, but that's okay because the exception says that boron and beryllium can have fewer than 8 valence electrons surrounding it. So this is a correct Lewis structure for BF3. Moving on, let's look at one last example of PCl5, right? And this example is really good to show the second exception to octet rule. So this exception says that third row and below elements can exceed octet rule, or can have more than 8 valence electrons surrounding it in the Lewis structure. Okay, so let's go straight ahead and count the number of valence electrons in PCl5, right? So first of all, we see phosphorus is right here in the 5A group in the periodic table, and we also notice that it's in the third row in the periodic table, right? So each phosphorus have 5 valence electrons. Next, we see that chloride is right here, right? And it's in the 7A group in the periodic table. So each fluoride has 7 valence electrons, and in PCl5 we got 5 chloride, so that's going to be 5 times 7. So in total, that's going to be 5 plus 5 times 7, giving a total of 40 valence electrons in PCl5 molecule. And now let's move on to step 2, which is drawing single bonds between bound atoms. Here I have phosphorus in the center and 5 chloride surrounding it. And I'm going to draw single bonds connecting each chloride with the center phosphorus. Lastly, step 3, we're going to arrange the rest of the valence electrons according to octet rule, right? So here we see that the center phosphorus already exceed octet rule because it has like 5 single bonds with each of the 5 chloride. So we're just gonna focus on filling octet rule for the surrounding chloride by having 3 lone pairs for each chloride. So next, we're gonna count the number of valence electrons we've used so far to satisfy octet rule for all those chloride. And after counting, I see that I've used 20 pairs of valence electrons. That's translate into 40 valence electrons, which is exactly the number of valence electrons we're allowed to use as calculated from step 1. And so we're done. This is going to be the final Lewis structure for PCl5. So we see here that all the surrounding chlorides satisfy octet rule, except for the center phosphorus atom. The center phosphorus atom exceeds the octet rule because it has 5 pairs of valence electrons, or 10 valence electrons, but it's okay, right? Because according to this exception to octet rule, third row and below elements may exceed the octet rule or having more than 8 valence electrons in the Lewis structure. And we see here the phosphorus is in the third row, so it's okay for phosphorus to have more than 8 valence electrons.